Hello everyone. In this video, we are going to talk about forward rates and spot rates and yield rates. This is actually a short topic. If you check exam FM, they actually have in sample question list, they have like around 4 to 5 questions. So I think it is worth if you learn this concept, because the problem wise when you go to exam FM, these forward rate, spot rate questions are easy to solve. So I think you should learn this concept. So first thing we want to talk about under this module, the yield curve. So let's think before we go to the yield curve, let's go back to bonds, and let's try to visualize it as a series of cash flows. Like it is a combination of zero coupon bonds. Okay. So bond can be viewed as a package of cash flows, with each cash flow viewed as a zero coupon. So you can always do that. So let's say you have n year coupon bonds. So then you can break it down to zero coupon bonds with one first one is, let's say these are year. So 1 year coupon, zero coupon bonds, then the 2 year zero coupon bond, and so forth. So then this would be a combination of zero coupon bonds. That's equal to the coupon bond. So let's say n year coupon bond. Okay. So that's first thing we want to understand. So any bond can be viewed as combination of zero coupon bonds. So next thing, so when we want to when we view bond as package of cash flow, or more specifically package of zero coupon instrument, so how do we calculate the bond value? So you have like these cash flows which maturing in 1 year, then maturing in 2 year, then maturing in 3 year, like in here. Okay. So should we use same yield rate to discount, or should we use a different yield rate, different interest rate to discount? So that's a question we need to think. So that's where actually how this entire lesson going to structure around that question. Okay. So the value of bond is the total value of all discounted zero coupon instrument. But what is the yield that should be used to value each zero coupon instrument? So the first thing we need to observe that in the market, there are so many bonds. First, you have the zero coupon instrument we call as UST bill. So these are 4 weeks, 8 weeks, 13 weeks, 26 weeks, 52 weeks maturing coupon instrument. Then you have UST note, which are semi-annual coupon bearing instrument with maturities of 2, 3, 5, 7, or 10 years. Then you have UST bonds, which mature in 20 and 30 years. Also, you have these TIPS and strips. TIPS are called as Treasury Inflation Protected Securities, and the principal is adjusted according to the inflation. So TIPS are currently offered on 5-year, 10-year, and 30-year. So basically, the coupon rate is fixed due to adjusting principle. So you don't have to worry about the inflation there. So because of that, coupon payments can be varied. Rate is fixed. Okay, so for example, coupon rate is 3%, but since the principal is adjusting, the coupon payment is going to be different depending on the time. Okay, so if there's a high inflation, you can have a higher principal amount. So then you get the higher coupon amount. The strips are separate trading registered in interest and principal securities. These are not US Treasury issued one, but using US Treasury instrument, one can create this kind of bonds by the other by the banks. Okay. So now, so first let's try to think about the yield to maturity. Okay. So yield to maturity, like even though here we discuss bond as series of zero coupon bonds or combination of zero coupon bonds, we are going to use one rate. So here I use rate I, then here I use the same rate to discount. Then for the 3-year, I use the same rate of discount, that cash flow. Then if I continue, this is the last one, the N-year one, which I have FR plus C, I use the same rate, I to discount. So the rate I found by making it equal to the price. So that would be the yield to maturity. So the idea is mathematically it's here. So you can see this side is the price, and you are discounting all cash flows under same rate I. Okay. So when that happens, so this rate I we call as yield to maturity. Okay, so you will see this lot of time. So that would be the that is the meaning of that. So basically, it's the internal rate of return. Internal rate of return is defined as present value of cash inflow equal present value of cash outflow. Whatever the rate you are using to do this, under which rate this is going to happen, that is called as internal rate of return. Or you can actually calculate something for the net present value under rate I, which is basically present value of cash inflow minus present value of cash outflow, and they set this to 0. So when that rate, basically that I star is called as IRR. So in the same, I mean, even the name is different, this is actually disguised internal rate of return. But under the bond contest, we call it as yield to maturity. So now once you define that, you can talk about bond yield curve. So what is the bond yield curve? So you have these instruments. So this side you have maturity. So basically yield against maturity. So you have, let's say, 1 month, 2 month, 6 month, 1 year, 2 year, 10 years, so forth, and you have these yield rates. Then when you combine that, it becomes a yield to maturity, I mean the yield curve. Now, one thing for sure, yield curve depend on the day. So if you calculate it today, and then if you do the same thing for the tomorrow, it's going to be different, okay? Because yield rates, they're going to be different for each, depending on the market condition, the yield curve is going to be different. So the yield curve is a graph that displays bond yield on the vertical axis and the time to maturity across the horizontal axis for a given day. For example, you can graph yield of US Treasuries on March 9, 2023. So by the way, it's depend on what kind of bonds. Okay, so you can have corporate bond, or you can have municipal bond. So depend on the bond type, the yield is different. So even though, so let's say you do this for US Treasury. Okay, so you do this for 2M, 3M, 1 year, so forth, and you get a curve. And then you go to another country, let's say UK, and then you do the same for the same kind of maturities. Okay, and you get a yield curve, same day. But then these two graphs are not same. Okay, so it's depend on countries, depend on what kind of bond. Is it government bond? Is it a corporate bond? Is it a municipal bond? So depend on the those things. It's actually yield curve change from one to another. Okay, and even the municipal one, you can have different type. It depend on the rating. Okay? So for some municipal count, some state they may have better rated bonds than some other state. Okay, so all of this depend on so many factors. Okay? So here you can see example. I draw two types of yield curve for two different dates for US Treasuries, and you see that we get two different yield curve. Okay. So it's depend on the day, depend on the type, depend on the country. So many factors. So so you can create yield curve for other types. So why do we use this yield curve? So then let's say, for example, so this blue color one is for March 9, 2018. Okay. So let's say I want to discount. So now basically you can kind of like so yes, you have these rates for only these days, but then you can interpolate, or you can do some curve fitting. And then, so let's say you have cash flow, which mature in 7 let's say 8 years. So you can find the yield rate to discount. Okay. So you can find the present value of cash flow, which mature in 8 years by using that rate. Okay. So that's the usefulness of this yield curve. So use the yield curve to predict, or you predict future movement. I mean, you can even extend it. I mean, of course, there's a risk associated with this. Okay, it may not be what you expect because it's depend on the day too. So tomorrow it may have something different. Okay, but anyway, for that particular day, maybe you can extend it, and then you can come up with a rate to discount your cash flows and see what kind of price you would like to pay for that particular product. So yield curve for other types of bonds, you can create yield curve for other types of bonds such as corporate bonds and municipal bonds. The approach is same. Now, so when you do this, you will see several types of shapes. So these are the three main type, and this kind of like in between hump shape. So let's discuss about why do we see this kind of shapes. Actually, there are theories about these shapes. Here I listed those shapes, those theories. Pure expectation theory, liquidity preference theory, preferred habitat theory, market segmentation theory. I would like you to search on these theories and find how they are explaining these shapes. But for now, I would just give some basic explanation why is this. Okay. So if I take this one, this would be the normal curve, or basically positive slope. So this side is maturity. So something like here you have like 1 month, and then this side would be like 30 years, and this side is yield. So what's happening? If you are investor, you are asking higher yield for 30-year bonds or 30-year maturity instrument than the one going to mature within 1 month very soon. So the reason is basically you are expecting economic growth. Okay, so basically expectation is economic growth. Okay, so if economic is going to grow, then what's going to happen in future? Like let's say in 10 years, it's going to be higher inflation. If it is high inflation, then you need a rate more than now to compensate or to have real effect on the return you are getting. So you need higher return. Okay. Remember, the real interest rate is what? Is basically inflation, the market rate, whatever the market offering, divided by inflation. Okay, so if you remember 1 plus 1 plus, depend on the years, 1 plus 3. Okay, so we had this formula. So this is the main reason. So you are looking at positive outlook for the future. So you would like to have higher return in 30 years, because let's say you are expecting 2% here, and then if you ask the same in 30 years, by then the inflation will take into will be higher than maybe 2% or 2%. So if you don't ask higher return, you will end up with negative return. So you would like to have higher return than what you're getting right now. So this may be like 7%. So the second one is inverted. So the inverted one is the other side. So you have negative outlook. So basically you are expecting recession. If it is recession, then what's going to happen? The future the rate's going to be low. So basically, you would like to have higher return now. So basically, the demand for the instruments maturing very soon would be higher than the demand for the instrument maturing like in 30 years. So that means basically you have to bring the rate down because of the demand. That would make the yield rate for those instrument down than the ones maturing right now. Okay. So this is the negative outlook. So in between, you can have flat. Okay, so for example, if you're going from recession to the inflation or the negative to the positive outlook, in middle you can have the flat curve, okay, or the other way too. You can have it become flat and then it goes to the inverted. So this is sometime also you can see that like the middle the instrument which mature in like middle like maybe 2, 3, or 5 years, they have a little bit higher return. So this is like more like uncertainty. Is it going to be recession or is it more like positive outlook? But it is more into the negative side. You can see that this side is harmed. So the weight more into the negative side. Um, so that is another shape you can see. So if you read this article, you can find more detail about the shape of the yield curve, and then the theory behind that is is given in here. You can type this name into internet, or you can get some textbook and search these names, and you can find some explanation. So we will meet again in next topic, the spot rate.